We move on now to our penultimate talk of the day, and we move to Richard Morey. And Richard is going to speak to us about a different title that he initially I'd suggested he might want to think about. And I'm going to give Richard the prize for the best title. And so no pressure, Richard, because I'm assuming the talk will be equally as good. So Richard Morey from Cardiff University.
All right, so I'm going to talk about something a little different. I thought it would be a bit of a black sheep topic here, but it turns out not to be. And I think you'll see that there are lots of connections between what I'm going to talk about and the previous talk. So I'm going to take a lot of the things that have been said by the replication movement and the people in it, and I'm going to reflect that back on people in the replication movement. And I'm going to name some names, but this is all in the peer-reviewed literature. Yeah, these have all been peer-reviewed. So let's talk about the replication crisis. I don't really know if we're in a crisis. It's called that. Maybe this is part of normal science. I'm not sure. But I do know that there are some pretty deep problems with psychological methods. And this could be part of the natural evolution of our science. But I think we talked about these over the course of the last few hours: questionable research practices, publication bias, oversold and underexamined results, badly thought out analyses, lack of transparency. All of these things exist, and they exist in spite of, and I want to emphasize this, good faith participation in science. This also applies to the people in the replication movement that I'm going to talk about. This is all part of good faith science. So there's been a lot of talk about incentives in science. So this is from Nosek et al. 2012. The incentives are for surprising, innovative results as strong in science. Science thrives by challenging prevailing assumptions and generating novel ideas and evidence that push the field in new directions. We must make incentives for getting it right competitive with the incentives for getting it published, right? And the problem is, if the incentives that we have are not truth and efficacy, then science becomes a sort of game that we play with one another. And this is the critical issue. As academics, we really love to argue about stuff. And if we become disconnected from truth and efficacy, then we end up arguing over nothing and playing games. So let's talk about the replication movement. Now, this is something that's not often said, but the methodologists and replicators, people in the replication movement, had exactly the same incentives as everybody else. Science is highly competitive, and it turns out that revealing problems in published research is sexy and counterintuitive. So we have exactly the same sort of pressures that we have on researchers, except now they happen to be for the methodologists and replicators. It turns out that many scientists don't understand statistics, and this cuts both ways. So researchers, they may use bad analyses in their work, but also they may not be able to answer the critiques of more statistically savvy people in the replication movement. And due to sort of literature isolation, that is, that psychologists and statisticians and philosophers don't tend to monitor one another's literatures, what you can get is statistical content that gets published in the psychological literature, and it takes a lot of time for there to be proper vetting of those statistical methods. So in this case, what do we expect will happen with our replication movement? Well, you might expect that there's going to be some poorly thought out ways of attacking research, because that's what you expect to happen, right? We have the same incentives for methodologists and replicators. So I'm going to talk about a specific case where I think we have a bad method that was used in this way. Now, I'm going to try to be very general about it, and this is the problem that I'm going to show you is general. It's not just for the method I'm going to talk about. It also applies to other meta-analytic methods, but I'm going to talk about a specific meta-analytic method that's used to critique research in psychology. So let me ask a question here. I have a set of 8 flips. The first 8 of them are heads. The last one is tails. And if I ask the question, are these coin flips biased? Your first reaction is probably they seem to be, but that's a bit of a trick question. Because these coin flips can't be biased. We have to talk about bias in terms of the process that led to them. So if I ask you then, what about the process that led to these heads and tails? Is that biased? But the way that this question has been framed has been, are there too few tails? Now, the analogy here is between heads and tails and significant and non-significant findings. With that in mind, think about these coin flips. We're going to make some assumptions about these coin flips. We're going to assume that these coin flips are independent. We're going to assume that each has a 0.5 probability of success. And we're going to assume that we pre-planned n flips, right? However many we see, in this case 8. And you can do this very easily. It turns out that the probability of 1 or fewer tails out of n equals 8 is p equals 0.035. So there seems to be something suspicious here. But we've made some assumptions here in order to get to those numbers. So let me show you actually what happened. This is 100 flips, and what I did was I looked at the ones that had 8. Now, normally this wouldn't be a problem because the number of coin flips that you do doesn't really matter if you've set ahead of time the number of flips that you're going to do. That would be suspicious. But if you look at what I've done here, you can see that every one of these patterns, every one of these sets of coin flips has the same pattern. They're all heads and then a tail. Because what I did wasn't set the number of coin flips ahead of time. What I did was, I'm going to flip until I get a tail. There's nothing wrong with that. I just had a different process for flipping the coins. And so when I asked the question, are there too few tails? Now the answer is different. So if I assume that the coin flips are independent, and I assume that each coin flip has a 0.5 probability of success, and we're going to flip until we fail, that is, we get a tail. Now, what's the probability of 1 or fewer tails? Well, I have just as many tails as I should have because every pattern has 1 tail at the end. Now my p-value is 1, and there's nothing unusual about that. So the point I want to make is that the coin flipping process is important. If you don't know the process, you can't actually evaluate whether that pattern is strange. Overall, if we look back at this, overall half of these coin flips turned up heads and half of them tails. That's exactly right. Everything is fine here. The problem was when I looked at that one and said that that was strange and made some assumptions that weren't true about it. So the process distributes them unequally. If I choose only to look at the large sequences, I'm going to be fooled about what happened. I have to look at everything because the groupings matter. And now we're going to talk about science. Science is all about the groupings of studies, right? We're looking for structure in our experiments. So the groupings are everything. So let's talk about the test for excess significance. So the question here is whether there are too few non-significant studies in a set. So these are the assumptions, the basic assumptions underlying it. We're going to assume that n experiments are independent from one another, and so these n experiments are typically from a paper, right? But if you think more generally about meta-analytic techniques, these are often collected by by the skeptic, and they're put in a set post hoc. So you estimate the next thing you do is you estimate the probability of success post hoc using a sort of power estimate, but none of what I'm going to say depends on that. But it's just analogous to the coin flip, except we estimate that probability, and then we're going to assume that the researcher pre-planned n experiments. Now, I don't know about you, but I've done a bit of science, and I know that that's not the way experiments typically work. Now, if you're doing a registered report or something, you can pre-plan experiments, but the scientific process is quite a bit more ad hoc than that, and there's nothing wrong with that being the case. To take a set of n experiments in the literature and assume that they were pre-planned, that's just a silly assumption. But this is the assumption of Ioannidis and Trikalinos and Francis, who I'm really critiquing here. Francis, 2013. So what happened was, by 2012, Francis had applied this to 8 papers. There was more on the way. And he had said that the results in these papers should be ignored. We should just ignore them on the basis of applying this test. The logical interpretation of a biased set of findings, that is one that triggers his test, is that they do not provide proper evidence one way or another. So he was actually taking papers and saying, just ignore those on the basis of this test. Now, in 2012, there was a special issue of the Journal of Math Psych, and statisticians were invited to comment. And this happened after there were 8 papers that he had critiqued this way. And what I'm going to do is I'm just going to provide you some quotes from the peer-reviewed commentary on the paper that talked about this test by Francis in 2013. This was my response. I said, the central assumption that studies can be thought of as coming from a fixed size group is violated. The assumption does not resemble actual scientific practice. Common violations of this assumption, such as sequential experimentation, are neither publication bias, nor are they problematic. This test was supposed to pick up publication bias, but it's not good for that. Because the consistency test, which is what he was calling it then, is questionable at best and completely misleading at worst, we should instead focus on changes in scientific culture to reduce publication bias. Vandekerkova, Guan, and Stierkala said this: without prior knowledge of the true effect size, the consistency test is unable to detect highly biased reports. Its lack of statistical power, combined with a propensity for flagging slightly biased, that is perhaps not even problematic, slightly biased rather than heavily biased reports, renders the consistency test all but useless as a tool in meta-analysis. Simonson said this, we mostly agreed. He said, what are we learning from these critiques of these other authors in the literature of scientific work? We're not learning that publication bias happens. We already knew that. We're not learning that the critique studies ought to be ignored because that doesn't logically follow from them containing publication bias. We're not learning that the critique studies have more severe publication bias than others because Francis's selective reporting of results and non-representative selection of studies to analyze in the first place prevents us from making such an inference. What then do we learn? That's rhetorical, just to make that clear, if it wasn't. Johnson said this. Val Johnson is a statistician, in case you don't know the name. I have concerns regarding the statistical methodology that he employs, as well as concerns regarding his guilt in committing sins of the very type he hopes to expose. Aside from the fact that the operating characteristics of the test are so poor, even more serious problems are encountered when one attempts to apply this methodology. In many cases, it's not clear which analysis and test statistics should be selected to test for an excess of significant findings. This goes back to the problem of constructing this test, or this set on which you're going to perform the test. So what happened? How could an unvetted method be used so many times against scientific work in the field? So that's my question of interest. And I think there's really three reasons here. We have a lack of qualified reviewers in psych. We have skepticism towards the attacked results. And this is likely to be, I think, justified in a lot of cases. We should have skepticism. But the problem is we don't have enough skepticism about the methods that we're using to attack science. And this was actually, so I quoted this was actually said to me by someone in the replication movement when we were discussing this particular method. They said, okay, well, maybe it's flawed, maybe you're right, but, it raises awareness of a problem. And as soon as you slip into that sort of thinking, you're playing the game. You're no longer in it for truth. You're playing the game. And we really have to be careful about this as methodologists. It's not just about awareness of some particular problem. We are critiquing individuals' science here, and we need to do it in a justified way, right? So this attitude is really concerning to me. So I think you should be skeptical of basically all meta-analytic forensic methods. This includes the test for excess significance. It includes funnel plots. It includes p-curving, which I'm working on a paper about now. They're often poorly vetted by statisticians and philosophers. They make untenable assumptions about the scientific process. Can you really define a trans-experimental process? How do those experiments fit together? And so we could end up in a situation where these methods wag the dog. That is, we're working to form our science so that they don't trigger these methods rather than doing good science. And they rely on hidden theoretical assumptions. Do studies have a well-defined grouping? Well, the way that we group studies is actually dependent on our theoretical viewpoint. And so that meta-analysis that you're going to put together is sensitive to that. And for skeptics to claim that their set is the one that makes sense, well, you can't verify that, right? Unless you actually knew what the underlying process was that you're trying to study, which you don't, that's why we're studying it. What inference should we draw when something is triggered here? Is it something about the set of studies? Is it something about the population? Is it something about the process that led to those studies? It's really not clear. And so, there's a tremendous amount of confusion about statistical issues in general in the replication movement. There's confusion about core statistical issues like power. There's too much trust in simulation, and I think this is really dangerous because science is not a random process. You can't fit it into a simulation. You can learn some things from simulation, right? But when you go out and you attack science with a simulation as your tool, you're going to be fooled. And I think we have a lack of critique of these sort of methods. There's a confirmation bias that exists in the replication movement about these. And even if you think that right now it's okay because there's a lot of bad science out there and these methods are just sort of exposing it, just wait until these methods are turned, when we clean all this up and they're turned against good science, we're going to regret that. Progress will suffer. So we really need good vetting of these sort of methods. And there are only difficult solutions to the replication crisis. There's nothing easy. We have to vet these forensic techniques in proportion to their potential impact. If we're gonna have very careful vetting of empirical work, we need to do the same with these methods. We need to solve the biasing process. These methods aren't helpful. We need to actually go to the root of the problem. We need a better understanding of the necessity of negative results and methodological transparency, so echoing what EJ said. And we need to slow down science. We need rigorous multi-lab exploration of phenomena. We need to stop these sort of one-off, very oversold sets of experiments that we see that we know are problematic. We need more confirmatory work, and we need to eliminate the incentives for game playing. I think these are the only ways out of the replication crisis, and we need to stop relying on poorly vetted meta-analytic techniques to root out what is replicable and what isn't. And that's all I have. Thanks.
Thank you, Richard. And I'm pleased to say your title and talk lived up to what I was hoping, so that was excellent. And I think Richard raises some really interesting issues there, and it's nice for the notion that we're reflecting back on the developments that we've been doing over the last number of years.